Hi, the diagram shows the shape XAYBX formed by two intersecting circles. The radii of the circles, centers P and Q, are 5 centimeters and 3 centimeters respectively. Then, at each of the points of intersection A and B, the radius of one circle is perpendicular to the other. So if this is 90, this could be 90 as well. Show that the angle APB is approximately 1.08 radians. We need to find this in radians. First thing, I would draw a line here, because that's a right angle triangle. This is the opposite, and that's the adjacent. So I can say I've got two of those, if there's theta and theta. So 2 times tan inverse of opposite over opposite over adjacent. So let's do it on a calculator. 2 times, in brackets, tan inverse of 3 over 5. So that's going to give us, there, 1.08. That's it. So that's 1.08, and it's been shown. Done. Second part, I want to find the perimeter of the shape XAYBX. Well, to find the perimeter, this is the major arc and the minor arc. So I want to find this angle here. This is quite easy. So you just take 2 pi, which is the complete angle, minus the inside one, so 5.20. And I can find its major arc. So AXB, arc AXB. That's going to give us r theta, which is then 5.2 times 5. So that's going to give us 26.011. So 26.0117 centimeters. I can also find the arc AYB. So AYB. And for this one, I need this angle first. And this should be 90 degrees here. So 90 and 90 is half pi and half pi. So I got then inside is 2 pi minus the other pi and pi, so that minus pi. It's going to give us pi. Take away 1.08. So 1.08, we're getting this angle here as 2.06 something. So we want the reflex angle of that, which is then 2 pi, take away what we just found, 4.2215. So let's say 4.22. Now if I want the arc here, it's r theta, so the radius is 3 times the angle, 4.22. So 3 times 4.22, and we're getting 12.66 centimeters. So you add these two up, and then you should be able to get the perimeter of the shape shown. So plus 26.0117, we're getting something like 38.7. Alright, so there we go. This is then 38.7 centimeters. Also the area of the shaded region, the area of the shape, this full area here, I can find major arc, minor arc. Okay, let's go ahead and find the area of the major arc. Area of major sector, my mistake. So that's going to be half r square theta, half times 5 to the square times 5.2. The area of the minor sector, and that's going to be equal to half times 3 to the square times 4.22. So I'm going to add these two up, and that's going to be, so let's see, 0.5 times 25 times 5.2, we're getting 65 here, plus 9 divided by 2, okay, times 4.22, and we're getting 18.99. So you add these, and this comes to 83.99 centimeters square. Remember, you still need to find the area inside. So inside I've got two triangles, Okay, two right angle triangles, so half base times height, half times the base 3 times the height 5 and multiply by 2 because there's two triangles. So we're going to say area of triangles is equal to 2 times half times the base times the height, and that should come to 15. So we're going to add 15 here. Let's see. Comes to 98.99. So the area is approximately then 99.0 centimeters square. So that's the area of this whole shape.